All right, then guys, if you'll turn to where we left off last time. Okay, we left off on number 12. Yes, Parker. I do? Okay, number 12. Anybody else need a blank copy? Okay. Yeah. All right. So if you take a look at number 12, okay, they give you an equation for f prime. Okay, they give you an equation for f prime. And they're asking you to find regular f. Okay, they ask you to find regular f. So for me to go from f prime back to f, that's an antiderivative. So I want you to rewrite your f prime here. Okay, this is what you were given. 6x squared plus e to the x. And then if I want to go back to regular f, I'm going to do an antiderivative on each side. Okay, which we learned last time is this symbol. Okay, it's kind of like an elongated S. The antiderivative of f prime is going to go back to regular f. And then do we remember the rules to do the antiderivative on this? You're going to add 1, then divide. So if it's x squared, it's going to go to an x cubed. And then divide the 3 on the 6. It'd be a 2. What about e to the x? What's the antiderivative of e to the x? Plus c. Okay, this is called the general solution. And the reason that it's called that is because your plus c is an ambiguous constant, which means it's standing in for basically any number that I want. Okay, if they give you an initial condition, you can actually find what that c has to be. So what I mean by that is, look right here. It says, given that f of 0 is 9, that means that when I plug in x equals 0, the answer should equal 9. And so I'm going to use that information in my general solution to find exactly what c is supposed to be. Okay, so let's go ahead and do that now. So here's my equation. I'm going to let 9 be the answer. So that'd be right here. And then everywhere that I see an x, I'm going to plug in a 0. So it'd be 2 times 0 cubed plus e 0 plus c. Okay, 2 times 0 cubed, what's that going to give me? 0. So I have 9 equals, but then e to the 0 is how many? 1 plus c. Then I can minus that 1 across. And now I know that my c needs to be 8. So knowing now that our c is an 8, we can adjust our equation that instead of a plus c, now it'll be a plus 8. Okay. So it'll be f of x equals 2x3 plus e to the x plus 8. Okay, and that is called a particular solution. Okay, versus when you're just calling it a C, that's called, like we said, a general solution. Okay. So you'll find your general solution first, use the point that they give you, solve for C, and then hone in on that particular solution. Let's do the next one. Okay, this time you have f double prime, and I'm trying to go back to solve for f. How many antiderivatives will I have to do to go from f double prime back to f? 2, very good. So let's start with f double prime. They gave us, it's a 12x squared plus 6x minus 4. And then remember to go backwards from f double prime, I'll do an antiderivative on each side. So integral here, integral here. The antiderivative of f double prime, what will we call that? F prime. And then just go term by term on this. Remember, you're going to increase the power, then divide. So my x squared will go to an x cubed. Then divide the 3 on the 12. Now that's a what? 4. My 6x, my x will go to a squared. Divide the 2 on the 6. Now it's a 3. What happens to the 4 by itself? 4x plus c. Okay, remember that's a general solution, but if they give me an ordered pair to go through, then I can find the c. Now, will I use this or this? The first one or the second one? Second one, because this is an f prime, then I have to make sure to use my f prime information. So I'm going to put right here, use f prime of 0 equals 4 to find our plus c. Okay, but then remember what that means is I'm plugging in 0 as the x and the answer should come out to be 4. So it would be 4 equals, this is now a 0 cubed, 3 0 squared, 4 times 0 plus c. And then on that one, all your zeros are basically going to drop off. That what will our value of c be? C will just be 4. Which means that my f prime of x will be 4x cubed, 3x squared minus 4x plus 4. Now, that's f prime, but I want to go all the way back to what? Regular f of x. Very good. So we're going to have to do the integral one more time. So I'm going to put my integral on both sides. F prime will go back to what? F prime will go back to regular f. Very good. And then I'll do my antiderivative rules on this equation over here. Remember, you're going to add 1, then divide by the new exponent. So x3 will go to x4, then divide the 4 on the 4, now that's a 1. X squared will go to an x cubed, divide the 3 on the 3, now that's a 1. X will go to x squared, divide the squared on the 4, now that's a 2. And then my 4 will go to a 4x plus c. Okay, then remember, that's a general solution. To turn it into a particular solution, I'll look at the initial conditions they gave me, but I need to make sure they use the one that goes with regular f, not the one with f prime. So I'm going to put right here, use f of -1 equals 7 to find the plus c. So that means that 7 is the answer when I plug in -1. Then from there, remember, -1, if you put an even power on it, is going to end up coming back to a positive. So -1 to the 4th, that's really going to come out to be a positive 1. Versus if I do a -1 cubed, 3 of them would stay negative. Okay, because they cross out in partners. Okay, here the order, you would square the -1 first, that would turn it positive. But then if you times it by a -2, that would stay a -2. Then a -4 plus c. What happens when you have a 1 and a -1? Yeah, just go ahead and cross those two out. So then I have -2 minus 4 more, that would be -6 plus C. And then remember, you'd add that 6 across to solve for your C. So what will our C value be? 13, very good. Okay, and then for your final answer, make sure you go back to your equation and plug that 13 in where the C was. So it would be f of x equals 1x4 plus 1x3 minus 2x squared plus 4x plus 13. Okay. And then remember the difference. This is a general solution. This is a particular solution. Okay. Questions on that? All right. We're just going to do one more. Go to number 14. Okay, you have on number 14, regular F. And what are they asking you to solve for? What kind of F is this guy? Capital F. So let's look back at your notes last time. Remember that F double prime goes back to F prime, goes back to F, goes to capital F. Okay. So put an integral on both sides. And then the little f is going to go backwards to capital F. What will cosine go back to? You're doing snow cone, but you're just going up. Sine. What will 2 go to? Plus C. And then from there, that's your general solution. To get to your particular solution, you'll give the information they gave you right here and plug that in. So capital F of pi halves is 7. That means 7 equals sine pi halves plus 2 times pi halves plus C. Okay, and then just make sure this number in parentheses is the one you put in the X spot. The equals number is what you put in the Y spot. Okay, sine pi halves. Which one's your pi halves finger? 0, pi 6, pi 4s, pi 3rds, pi halves is your thumb. And then sin is you want all the fingers down. That'd be root 4/2, which is the same as 2/2, which is 1. So that'd be 1 plus. What is 2 times pi halves? Yeah, basically just a pi because you can cross those 2's out. Plus C. Let's minus that 1 across. So I have 7 minus 1 is 6 equals pi plus C. And then to solve for your C all the way, you'll just minus the pi across. So it'll be C equals 6 minus pi. And then I would go back to my general solution where my C is, and I would plug in a 6 minus pi in that spot. So capital F of x equals sine x plus 2x plus 6 minus pi. And that would be your particular solution. Okay, do we feel okay about that? All right, go ahead and transition to your notes for today. Okay, so what we're going to do is the exact same stuff that we were doing before we learned how to do an antiderivative. Okay, that deals with particle motion, position, velocity, and acceleration. So at the top of your paper, I want you to put PVA. Okay, that stands for position, okay, position, velocity, and acceleration. When you take the derivative, you're going down the list. So now antiderivatives will help you go backwards up the list. So if I take a look at this question, it says we have a particle on the x-axis, and they're giving us the acceleration equation. If I have the acceleration equation, how will I make it back to velocity? What will I do, a derivative or an antiderivative? Antiderivative, very good. So if I want to go from acceleration up to velocity, that's an anti. So go ahead and rewrite your acceleration here. Yeah, can we put the computer up and now, please? Okay, and then put an integral on both sides. So acceleration, when I integrate it or do an antiderivative, is going to go back to velocity. And the integral of acceleration is now v of t. And then the integral of 6t minus 18, we'll just use our normal rules on. What's that antiderivative going to be?
Minus 18t plus c.
Perfect. Okay, and then now we need to know some velocity at some time for us to find what c is. So let's go back and read our question. Here's what it says. I'm starting where I left off. At time 1, the particle is traveling to the left at a speed of 36 meters per second from a position 10 units to the right. So here's what they've given you. Let's put right here, given. What time did they give us? 1. And they're telling us it's traveling to the left at a speed of 36. Then the velocity of 1 is negative 36. Okay, think about if that makes sense. Okay, the speed tells me how fast. The left means I need to put a negative on my velocity. Okay, then it also tells me the position is 10 units to the right. Should that be a positive or a negative? If you're on the right side, that would be positive. Very good. Okay, and then I'll use that to find my constant. Now, will I use the velocity or the position for part A? The velocity. So my v of 1 is negative 36. Then negative 36 should be the answer when I plug in a 1. So 3 times 1 squared is a 3. Minus 18 times 1 is 18. What is 3 minus 18? Negative 15 plus c. And then if I add that 15 across, what will my constant be? Negative 21 is correct. Very good. So my velocity, I'm going to write it up here, is 3t squared minus 18t minus 21. Now, the next set of questions are already things that you should know how to do. If I want to know when the particle is traveling to the right, what would I do with this velocity equation? Factor it, good, and then I'm going to do a number line on it, right? So if I want the particle traveling to the right, I'm going to set this equal to 0. I see all those numbers can divide by 3. So that'll give me t squared. 18 divided by 3 will go to a 6. 21 divided by 3 will go to a 7. And then I need numbers that times to 7 and subtract to 6. But with 7 being prime, I can really only do 1 and 7. Which one will need to be negative? The 7, very good. Which means that my critical numbers, or my at rest times, would be -1 and +7. Which of those would I eliminate because it doesn't make sense? No more -1, very good. Okay, from there, set up your number line. Remember, number line starts at 0, and we're going to label this velocity. 7 is my critical number. And then if I pick a number bigger than 7, say I pick 8. 8 minus 7 is positive. 8 plus 1 is positive. 3 is positive, so that's going to be a plus. Less than 7, let's say I pick 6. 6 minus 7 will come out how? Negative. Okay, but then the 6 plus 1 will be positive overall, though it'll give us a negative sign. So my particle would be traveling left and then right. Specifically, the question's asking on what interval it's traveling to the right. So we would say from 7 to infinity. If it asks you to justify because velocity greater than 0. Okay, that would be your answer. If I wanted my particle traveling to the left, then I'd be looking for a negative velocity and I would have put 0 to 7. Okay, next question. I want velocity decreasing. Velocity decreasing means that its derivative needs to be negative. What is the derivative of velocity called? Acceleration. Do I need to find acceleration? No, that's what they started us with, right? So acceleration is 6t minus 18, and I'm going to set that equal to 0. Take a 6 out. That's a t minus 3. Which means that my critical number is just going to be 3. Okay, this is an acceleration timeline. Bigger than 3, let's say we pick 5. 5 minus 3 is going to be positive for the right side, and then negative for the left side. Now remember, acceleration tells me what velocity is doing. If my acceleration is negative, then my velocity would have been decreasing. And when my acceleration is positive, my velocity would have been increasing. So what interval is my velocity decreasing here? 0 to 3, and then we'll just put because acceleration less than 0. Okay, the next question's almost the same, but you want speed decreasing. Do we remember what we're looking for when we're looking at speed? Yeah, the velocity and the acceleration need to have opposite signs. So remember, for speed, you're going to do a double sign chart. Okay, where you're comparing the signs of velocity and acceleration. But keep in mind, you've already made both of the number lines, you just need to stack them. So I'm going to do that right here. My velocity critical number was 7. It went minus plus. My acceleration number line changed at 3 and it went minus plus. And then I'm just going to put the pluses across the bottom since there's kind of a big gap. And then I'm looking for opposite signs. When does that happen?
3 to 7.
3 to 7. Okay, versus if you wanted it to be speeding up, you'd want them to be the same sign. So we'll put 3 to 7 because opposite signs. All right. Next question asks me to find position. So look back at that little chart that you made up here in the corner. They started me off with acceleration. I did an antiderivative to get to velocity. So now if I want position, I'm going to have to antiderivative again. So rewrite your velocity equation, and then we're going to integral on both sides. So your velocity equation was 3t squared minus 18t minus 21, integral. The antiderivative of velocity is going to bring us back to what? Position, which would be x of t. And then go ahead and do your rules on that polynomial. Remember, you're going to add 1, then divide. Add 1, then divide. So powering that up would be t cubed. Divide is a 1. T would go to squared. That'd go to a 9. Minus 21t plus c. Then to find my c, what position did they tell me in the question that I can use here? The position at 1 is what? 10, very good. So I'll do 10 equals, and then I'll plug in a 1 here.
We're putting it on because
Correct. Versus if it had said like the initial position, you'd let your t be 0. So 1 cubed times 1 is all 1. That'd be a -9 minus 21 plus c. -9 minus 21 would be -30. And then if we add 1 to that, that'd be a -29. And then if I'm trying to solve, I have to get rid of the -29. So I would add that across. What would my c be? 39. Very good. So then let's write our x of t up here in part E. 1t cubed minus 9t squared minus 21t plus 39. All right, last question that it asks you is if the particle is initially traveling towards or away, what 2 things do you have to consider for towards or away? There are only 3 choices out of position, velocity, and acceleration. Which ones matter for towards or away? Position and velocity. And if it says initially, what time do we care about? 0. Very good. So for part F, we're going to find the position at 0 and the velocity at 0. Okay, now 0 is the easy number to plug in because it's going to basically cross everything out except the c. So position would be 0, 0, 0 plus 39. And then my velocity was written right here. So it'd be 0, 0 minus 21 would be minus 21. Okay, then from there, let's talk about what that tells me. If my position is positive, am I on the left or the right side? On the right side. And then my velocity is negative. Which way are we traveling? Left. So we're on the right, but we're traveling left. Is that towards or away? Towards. Very good. Okay, but that's not really a new concept. The only thing that's kind of changing today is rather than you taking derivatives to get velocity and acceleration, you'll start with acceleration and do antiderivatives to get back to velocity and then position. Okay? All right, I think we're only going to do one more of these all the way through, and then I'm going to give you the rest of the time to just kind of work on stuff. What? You do. So we'll do number 3. Okay, kind of nice and short. All right, acceleration equals e to the t. Part A, you're asked to find velocity. What are you going to need to do? Antiderivative, very good. All right, one more left. We're almost done. Nice short notes today. So A of t will go back to what when you do an antiderivative? Okay, V of t. And then E of t will go to what when you antiderivative it? Plus c, very good. Then you got to go back in the question and find whatever initial condition you can use to find your velocity. So I'm going to put given here. And then I want you to read through that and write your statement of what you know. So it says at time t equals 0, the velocity of the particle is 6. So V of 0 is 6. And its position is 16. Is that correct?
Yeah,
Negative 16 because it's 16 to the left. Okay. All right, then from there, we'll use our V of 0 equals 6 to find our C. I'll give you a second to do that. Make sure you're using V of 0 equals 6, not X of 0. So then I would do 16 equals e to the 0 plus c. Will my c end up being 16? Oh crap, I wrote the wrong number, sorry. Okay, now it's a 6. So 6 equals e to the 0 plus c. Will my c end up being just a 6? No, because what's e to the 0? 1, and you're going to have to minus that across, so your c should be 5. Very good. So let's rewrite our velocity here. V of t equals e to the t plus 5. Okay, part B asks you to find the position. That means we're going to have to undo one more antiderivative. So integral. What does velocity go back to? Position, x of t. And then e of t goes back to e of t again. My 5 goes back to what? 5t, or 5x is the same, and then plus c. And then I can use this condition to find my c for position. So it'd be negative 16 equals e to the 0, 5 times 0, plus c. We know our e to the 0 is going to come out to be a 1, and then we're going to have to minus that across. So what is my c going to end up being for this one? Negative 17, very good. Which means my position equation is going to be e to the t plus 5t minus 17. Okay. All right, then because you have an e in this, you really can't do a sign chart on it. But if they give you particular values, you should still be able to answer these two questions. So part C asks about towards or away. What am I comparing? Position, velocity, or acceleration? You need 2 of them. Towards or away, we need position and velocity. And remember, you don't really care about the exact value. You just care about if it comes out positive or negative. So let's say I'm plugging a 1 into the position equation I just found. I'd have e to the 1, okay, which is about 2.5. Okay, then plus 5 times 1 is a plus 5. And then minus 17. How's that going to come out? Negative. So I'm going to put less than 0. Okay, I don't know the exact amount, but I know it's going to be negative because e plus 5 is about 7. And then if you take away 17, that'd be negative. Okay, let's do the same thing for velocity. Velocity's here. I'd have e to the 1 plus 5. How's that going to come out? Positive. So if my position is less than 0 and my velocity is greater than 0, am I on the left or the right side? I'm on the left side, but which way am I traveling? Traveling right, is that towards or away? That would be towards, very good. Okay, then last question like that says speeding up or slowing down. For speed, which of the two things am I comparing between velocity, acceleration, and position? Velocity and acceleration. Now, v of 1, I already just did, so I already know that's greater than 0. But I'll have to check acceleration at 1. And remember, acceleration is the initial equation they gave me here. Remember, it was just an e of t by itself. So it'd be e to the 1. Is that positive or negative? Positive, which means they're both positive. So is it speeding up or slowing down? Speeding up. And then I'll put because v of t and a of t, same sign. Okay, also remember, they don't have to both be positive. They just have to both be the same type. Okay? All right, these other examples didn't really have anything new. So I think we're just not going to do them, and I'll just give you time to work on your homework. Okay? You have about 50 minutes.
This one, yeah, but what's kind of like. How did you go to bed, bro?
Yeah, we got
12:30. I'm not gonna be long. I'll sleep here.
Just email me when you're done with it and I'll take the late penalty off. I have napkins.
You gonna ask me this No, no.
Like this.
Don't want any scratch paper over here. Eric?
There you go. That's what I do. I do.
Questions or recess? Yeah.
Hi.
Yes. You want paper? The one that I emailed you? Okay, so you know, do you want paper? Okay, y'all want paper?
Two. What did you do, Carly?
Y'all want paper?
Okay. No. Oh, this is next Monday. Mr. Orange says one.
Wait, I said what?
It's our bill.
On Thursday?
We're done with that. Just kidding, Greg. Why not? Good.